Hi, everybody. This is taking the derivative using the chain rule. Okay, so in these problems, we're going to use the chain rule. So if you look in a calculus book, they give you these formulas. They all mean the same thing. Taking the derivative of y with respect to x. Taking the derivative means you take the derivative of y with respect to u, and then you take the derivative of u. What does that mean? Wait, we're taking the derivative of y, then we're taking the derivative with respect to u? Well, the chain rule is usually a little bit more complex of a function that's harder to take the derivative. So if there's a way to make the function easier to take the derivative of, we do that. We substitute a value, we're going to call it u, into the function, and then take the derivative of that function afterwards. In other words, this is the formula I really like to use. These all mean the same thing, by the way. Over here, we had the derivative, we had x. We're using the variable x. If we change not just x, but some form of the expression of x, to u, then take the derivative. Then you also have to take the derivative of u. You'll be able to take the derivative very easily. So let's take a look at a problem here. So if you look at this, the only way you could take the derivative of this function is if you multiply this all out to the third power, FOIL it, distribute it all out and multiply it. However, remember, if I can make this function look a little easier, let's make the inside of this, change that to u. See, I'm just changing the inside of that to u. So now I'm dealing with this function, u to the third. And I can take the derivative of u to the third. Okay, so remember our formula that we're going to be doing. I'm going to go back one slide. Right here, we're going to take the derivative with respect to u if we can change something to u, but then we have to take the derivative of u. So I'm going to take the derivative of this u to the third, but then, so first I'm going to take the derivative of this new, I'm going to take the derivative of this new u function, and then I'm going to take the derivative of u. Okay, so the derivative of u, of this function here, I'm going to put it over here. So the derivative of that function is 3u to the square. And then then I need to take the derivative of u. Okay? Well, here's u. The derivative of u would be 3 minus 4x. So u prime equals 3 minus 4x. This equals 3 minus 4x. This equals 3 times u squared. Well, u equals 3x minus 2x squared. And we're done. That's the derivative of this entire function. So our goal is to make this simpler. So I'm going to erase this and try this again. Just look at it again. If I make this part u, I end up with u to the third. Now, taking the derivative of this, I get 3u to the third, and I don't get 3u to the third. I get 3u squared, and then I have to take the derivative of u. If this is u, the derivative of u is 3 minus 4x, right? This cancels out and then the 2 comes here and you subtract 1. So now we're just plugging. Once you have the derivative, this is our derivative. It's not our answer because our original problem is respect to x. The only thing we need to do now is plug everything back in. We have 3 times u squared times u prime. Well, u prime is 3 minus 4x, and u was 3x minus 2x squared. You don't need to multiply it all together. This is what the answer looks like. So we can take the derivative of a more complex function if we can simplify it by making something u and then being able to take the derivative of that u. So let's try another one. Look, let's make u the x squared minus 1, this stuff in here. So if I rewrite this function, I have u squared inside the third root. You see, this is u. We said u is x squared plus 1. Another way of writing this function, a little simpler, is u to the second power and third root. You can put it in exponential form. Well, I can take the derivative of this. The derivative of this equals 2/3 u, and if I subtract 1, 2/3 minus 1 is a negative 1/3. And don't forget, you have to take the derivative of u after that. That was part of that formula. So the only thing left now is to plug everything in. If this is u, then u prime, the derivative of u is 2x. So let's plug everything in. 2/3 times u to the negative 1/3 times u prime, and u is x squared minus 1, and u prime is 2x. So this is the answer. If you want to simplify it maybe a little, I'm happy with this answer, but let's say we wanted to simplify it. This x squared minus 1, this negative goes to the bottom, right? We have 2/3, and this is the third root. So I can change that to the third root of x squared minus 1. And then we just have 2x on top. 2 times 2 is 4, so you can rewrite that as 4x. 3 to the third root of x squared minus 1. So this looks a little cleaner for an answer. All right, so the goal is just to try to make something into u. Unfortunately, I tell you everything that's u and u prime and all that. I tell you what you should change to u, but during the homework, I'm sure you'll have to figure it out for yourself. So if you look at this, I have 2 expressions multiplying together. So I'm going to have to use the product rule. Remember the product rule when you have 2 functions? The product rule is take f and then take g prime plus g and f prime. If I take the derivative of a function h, I have to take f times g prime plus g times f prime. So I'm going to call the first expression f and the second expression g. So if I get f, I get x squared, and the derivative of f, or f prime, is 2x. Now if I say g is, let me write it like this, 1 minus x squared to the 1/2 power, I have to find g prime, the derivative of this. Well, you got to be careful. You have to use the chain rule for the derivative of this. So down here, I'm going to use the chain rule. I'm going to say this part equals u. U equals 1 minus x squared. So the derivative of u equals a negative 2x. So to do this problem, we have to take the derivative. I'm going to erase this just for a second. That's really didn't erase it, but it's like saying u to the 1/2 power, right? This is my u. So now the derivative of g, I bring the 1/2 in front, u, and subtract 1, and I get a negative 1/2, and then derivative of u, or u prime. That's not u to the 1, that's u prime. So that's my answer to that part, to g prime. So g prime actually equals, I'm going to bring it down here, the derivative of g then equals 1/2 u to the 1/2 power, and u, I stated u was this. So this is 1 minus x squared to the 1/2 power, and then u prime, and we said u prime was a negative 2x. And if I simplify this a little bit, that's a g. That's supposed to be a g here. Negative 2x times 1/2 is just a negative x. So there's my g prime. There's my g. There's f and f prime. So taking the derivative of this function, I have two terms. I have to put f here, then g prime plus g f prime. All right, so f is x squared. F prime way over here is 2x. G is, I'm going to write it in square root form, the square root of 1 minus x squared. And g prime, wait, that's g prime. I put the wrong one in there. G prime is 1/2 with the square root on the bottom. Do you see it's a negative 1/2? Square root of, I have it down here. I'm sorry. G prime is down here. Negative x with a 1 minus x squared. And since it's to the 1/2 power, I don't think it's to the 1/2 power. It should be to the negative 1/2 power. Yes. We had g, and then we had g prime is the negative 1/2 power. Boy, it's just getting so messy here. I apologize. That should be the negative 1/2 power. So in reality, we have negative x, and the negative takes it to the bottom, the square root of 1 minus x squared. Then g equals the square root of 1 minus x squared, and there's our answer. Now, we could clean it up a little bit by multiplying these two together. You get x3 over the square root. It's not letting me write now because I'm too low. We get negative x3 when you multiply these two together over the square root of 1 minus x squared plus these two multiplied together, which is nothing special. So there's my answer. So you had to use the product rule, and then you had to use the chain rule when you're using the product rule for the second part. That's a lot of work. All right, let's try this. We're going to call this whole thing here u. So what we have is u squared. And if I want the derivative of that, the derivative of u squared is 2u, and then u prime, derivative of u, right? You bring the 2 in front and you subtract 1. And you get 2u prime. So I know what u equals. I just have to find u prime, the derivative of this. Well, in order to take the derivative of this, you have to use the quotient rule. And you guys are going to make me quotient. The quotient rule. And the quotient rule is if I take the derivative of a function, let's write the function. Let me just show the formula first. Here's a function, and we have f and g. The quotient rule says you take g f prime minus f g prime and divide it by g squared. So that's the quotient rule. If I have a fraction and I have a function on top and a function on the bottom, I have to take the bottom times the top prime minus the top times the bottom prime divided by the bottom squared. So I need to set all this, my g, or my f, the top, f equals 3x minus 1. So the derivative of f equals 3. G is the bottom equals x squared plus 3. So g prime equals 2x. So to find the derivative, I have to plug it into this formula. G goes first. G is x squared plus 3 times f prime, which is 3, minus f, which is 3x minus 1, times g prime, which is 2x, all divided by g squared. So if I try to simplify this a little bit, Lord help us, when I run out of room, I freak out. I get 3x squared plus 9. That's x squared plus 3, right? Yeah. 3x squared plus 9. And then I distribute this negative 2. I get 6 minus 6x squared plus 2x on top. So if I combine like terms, I end up with negative 3x squared plus 2x plus 9. Okay, so that's my top, and my bottom is that x squared plus 3 squared. This, once again, this is this u primed. This right here is u primed, the derivative of u. So here's my function. The derivative is 2 times u, and u equals this, times u prime. And u prime equals this. So you can try to simplify this. Do you see if you multiply this and this together, on the bottom you end up with x squared plus 3 to the third power. On the top, you don't need to multiply it together. There's a negative 3. I would just leave it like this. And this looks like that's the answer I would use. I mean, if it was multiple choice and they wanted you to simplify some more, combining like terms and multiplying, do it. I don't think they do. They just wanted you to see if you can go through that process. All right, let's try a couple of more. Sine 2x. I hated that they're telling us what u equals. I know how to take the sine, the derivative of a sine. So we're calling this sine u. U equals 2x. If u equals 2x, then the derivative of u equals 2. So here's my function, and with respect to u, if I take the derivative of that, the derivative of sine u is cosine u. And don't forget, we have to do u prime. So the last step for this is always plug in the x's back. Cosine, well, here's u. U is 2x. And then times the derivative of u, which is 2. And normally you don't leave that 2 out in front, like out in the back like that. You bring it to the front. So there's what our answer would look like. And this looks like it could be my last one. So if we're going to change something to u, it's going to be the 3x. So if u equals 3x, then the derivative of u equals 3. Do you see how for u, we pick something we can differentiate? So to take the derivative of this function, it's going to be the derivative of e to the u power, or e to the x, is the same thing. It's e to the x, or in this case, e to the u. Don't forget we had to take u prime. So, and I'm going to change u back to what it's supposed to be. U is supposed to be 3x, e to the 3x. And then u prime, the derivative of u, this is u prime, same thing, is 3. And I like to bring that 3 out in front. There's our derivative. All right. So I did notice in this section of the book, there's a couple of other things we should learn. And these should be on like your formula sheet for derivatives. The derivative of the natural log of x is 1 over x. The derivative of the natural log of u is 1 over u times u prime, right? Then you take the derivative of u if you want to change it to a u. And there's some other derivatives for bases other than e on here. You can take a look at those, or go to your book and take a look at those. So let's take a look at this problem here. If I have 2 to the u power, and I say u equals 3x, do you see? I can find the derivative of 2 to the u power right here. A is a constant in this problem, 2 to the u power. The answer is, if a equals 2, then we put a 2 everywhere in here. Do you see? And this is the derivative of u here. So in this problem, I'm gonna transform the formula ln a times a to the u ln a times a to the u, then u prime. If you look at that formula, ln a times a to the u, and this is u prime. This is the derivative of u with respect to x. And in our case, we said this is a equals 2. So if we're going to take the derivative of this, we're just going to plug it straight in. ln a is 2 times 2 to the u power, and u is 3x, times the derivative of u. And we haven't found the derivative of u yet, but the derivative of u is 3 times 3. So finally, once again, you put that multiplying 3 out in front, ln 2 times 2 to the 3x power. And that's how I would answer the question. I hope this worked. This is called the chain rule, taking the derivative using the chain rule. Definitely practice these. I gave you all the u's. Well, when you're doing this yourself in the homework, you're going to have to create these u's on your own and then take the derivative of u. And don't forget to plug the x's back into the u's at the end of the process, because we're still taking the derivatives with respect to x. We change them to u to make it easier to take the derivatives, but then we substitute the x's back in. I hope this video helped. You guys have a great week.